Let us begin by introducing what we are learning today. Time-based grouping and aggregations with Pandas. In this lesson, we will unlock the power of Pandas for handling time series data. You will learn how to group, resample, and aggregate data by dates, months, or years. We will use the classic flights dataset. This dataset contains airline passenger numbers over time. By the end, you will build your own mini time series analysis in Python. Running the cell now. Let us get started by loading our dataset. First, we will load our dataset and preview what it looks like. We turn off warning messages to keep our output clean. Now we are importing the Seaborn library. It includes some built-in datasets for practice. Import NumPy as NP. We set the random seed to 42 for reproducibility. Here we load the flights dataset. It holds monthly air travel totals, perfect for time series lessons. Let us check how many rows and columns our data has. We view the first 3 rows of the flights dataset to get a sense for the structure. Running the cell now. This output confirms the dataset shape and structure, showing 144 rows and 3 columns, year, month, and passengers. Notice the key time-based columns year and month, which are essential for grouping and aggregating flight passenger data in time series analysis. This sets the stage for exploring how Pandas can manipulate and summarize data based on dates. Practice, try running df.tail to see the last few rows yourself. Let us discuss why time-based grouping is so useful. Why time-based grouping? Many real-life datasets track things over time, like sales, weather, traffic, or stock prices. We want to answer questions like: how many passengers flew each year? Which month is the busiest? Are there seasonal trends? To do this, we need to group and summarize by time with Pandas. Running the cell now. Next, we will make sure our data is ready for time analysis. Before any grouping, it is good practice to check the types of our columns. Here, we look at the data types for all columns. Time analysis works best when dates have the proper type. We print the data types of each column to understand the kind of data we are working with. We print the column names to be sure what is in our dataset. This double check helps avoid surprises later. Running the cell now. Here, we're confirming the structure of our dataset before grouping by time. Notably, that a year column is an integer, and a month is a category, which is important for efficient time-based operations. This ensures we can accurately count passengers per year in the next steps. You should always check D-types before grouping by dates. Let us make a real datetime column from year and month. Here, we merge this year and month into a string. We then convert that combination to a proper datetime using Pandas. The result is a new date column we can use for analysis, which Pandas recognizes as a time object. We preview the new column to see it worked. Running the cell now. This output shows how separate year and a month columns are combined into a single datetime column named date, standardized to the first day of each month. Notice the new date column's consistent YYYYMMDD format, which simplifies time-based grouping and analysis. This step is crucial for answering questions like yearly or monthly trends in passenger counts by enabling smooth date handling. Try making your own datetime column in a different dataset for practice. It is always safer to sort by date before plotting or resampling. Here we sort our data so the earliest months are on top. This ensures that future calculations and plots display in the right order. Let us quickly check the head to confirm they are sorted. Running the cell now. This output shows the first 3 rows of the dataset, sorted by date to ensure chronological order. Notice the clear time progression from January to March of 1949, with passenger counts recorded monthly. Sorting the data prepares it for accurate time-based grouping, which is essential for analyzing trends over years or months. When analyzing time data, always check the order. Now, let us see how the passenger numbers change over time with a quick visual. Visualizing time series data, first look. Before grouping or aggregating, it is helpful to draw a simple time series chart. This quickly shows any patterns, outliers, or trends in the data. Running the cell now. Let us plot the data next. Let us build a line chart to show how passenger counts change each month. We import the matplotlib plotting library. The figure size is set to be wide and not too tall, making it easy to read. We plot passenger counts on the y-axis and date on the x-axis, drawing a dot for each month. We add a descriptive title to the chart. The x-axis label makes clear we are tracking the date. The y-axis label explains that the numbers are passenger counts. Tight layout ensures labels are not cut off. Finally, we show the chart so you can spot the trends right away. Running the cell now. The plot displays the number of passengers over time, revealing clear seasonal fluctuations and an overall upward trend in travel. Notice the regular peaks and troughs, which indicate cyclical patterns within each year. This simple visualization helps us quickly identify key trends and variations before performing any grouping or aggregation on the time series data. After plotting, ask yourself if you can spot any yearly or monthly cycles. Now, let us group by a year to see the total number of passengers each year. Here we use Pandas groupby method to bundle all rows sharing a year. For each year, we add up the passenger numbers. The result is a table showing one sum per year. Running the cell now. This output shows the total number of passengers for each year, summarizing the time series data by year. Notice the clear upward trend, indicating growth in passenger numbers over time, which helps validate the presence of a long-term pattern before creating detailed visualizations. This initial aggregation is key to understanding overall trends before drilling down into monthly or seasonal variations. Can you use mean instead of sum to get the yearly average? How about monthly patterns? Let us rank months by their average passenger numbers. We group our data by this month column and compute the mean number of passengers for each month. Sorting these means from highest to lowest, we can see which month is busiest on average. Printing shows monthly patterns for planning or reporting. Running the cell now. This output shows the average number of passengers for each month, sorted from highest to lowest. Notice that the summer months, July, August, and June, have the highest average passenger counts, revealing a clear seasonal trend in the data. This confirms the value of visualizing time series data early on to identify such meaningful patterns before deeper analysis. Look for the peak season the months high on this list. Now we will show how to use the datetime column as the data frame's index. Using datetime as index. Setting datetime as the index unlocks powerful time-based features like resampling, shifting, rolling, and more. Let us make date the index for our data frame. Running the cell now. Watch how this small tweak enables big changes. Let us switch to a time series index. We use set_index to use date as the route label. This tells Pandas that rows are naturally ordered by time. Previewing helps verify it worked. Running the cell now. Here, we set the date column as the data frame index, which you can see now appears on the left as a datetime index. Notice how this transforms our data structure, enabling us to efficiently access and manipulate time-based information, such as resampling or rolling calculations in future steps. This setup is foundational for time series analysis, as it aligns the data around chronological order automatically. Setting a datetime index is a key habit for time-based work. Let us use Resample to quickly total passengers for each year. Now that date is our index, we can call Resample with Y to choose yearly windows. We sum passenger counts to get the total for each year. The output is a time index summary with just one line per year. Running the cell now. Here, by setting the datetime index, we resampled the data by year and summed the monthly passenger counts to get annual totals. Notice the index now reflects year-end dates, and the values show a clear upward trend in passengers over time. This demonstrates how a datetime index enables easy aggregation and time-based analysis. Try resampling by quarter using queues as another experiment. Let us smooth numbers with a moving average. We call the rolling method with a window of 12 months, which is 1 year. For each month, we take the mean of itself and the previous 11 months, then store it. Previewing both columns helps us see how the rolling mean changes compared to the original. Running the cell now. Here, setting the datetime index allows us to apply a 12-month rolling mean on the passengers column, smoothing out short-term fluctuations. Notice how the first 11 months return none since a full 12-month window isn't available yet, and from the 12th month onward, the rolling underscore mean gradually reflects the average passengers over the past year. This highlights how datetime indexing enables time-based operations like rolling averages to better analyze trends over time. Rolling averages reveal trending up or down, even with noisy data. Let us visualize the effect of our rolling average next to the raw data. We open a new figure for this comparison chart. First, we plot the original time series in blue. Next, we add a red line showing the rolling mean over time. We put a title so it is clear what the lines mean. We label the x-axis as date to indicate the time dimension. We label the y-axis as passengers to show what the values represent. A legend helps viewers know which line is which. Tight layout makes sure everything fits. We display the chart, so ups and downs are easy to spot. Running the cell now. This plot compares the original monthly passenger counts with their 12-month rolling average, clearly showing seasonal trends smoothed out over time. Setting the datetime as the index allowed easy access to the time series data for both plotting and calculating the rolling mean, highlighting trends and fluctuations more effectively. Notice how the rolling mean, red line, smooths short-term noise, emphasizing the overall passenger growth trend. Practice, try a rolling window of 6 months and see if the lines get smoother or choppier. Let us pull together these ideas for a hands-on challenge. Mini project, find peak travel season. Let us combine what you have learned. Your task: find the month and year when air travel peaked. Tip: you can use IDSMAX and LOC to solve this in code. Running the cell now. Pause and try this before moving on. Can you extract both the date and passenger count for the peak? Let us reveal the best month and its passenger count. Here, we use IDSMAX to get the date for the route with the highest number of passengers. We also get the actual passenger number using max. Printing it together creates a clear answer to our mini-project question. The result is human-readable, showing both month and number. Running the cell now. This output identifies July 1960 as the peak travel month, with 622 passengers, the highest count in the dataset. Notice how the code uses IDSMAX and max to pinpoint when and how many passengers traveled, directly supporting the project goal of finding the peak travel season. This method efficiently highlights key trends in time series data by focusing on maximum values. Try swapping IDSMAX for IDEXMIN to find the least busy month. Let us now organize data by quarter, 3-month periods. We resample to quarter-long windows using Q for quarterly. For each window, Pandas calculates the mean number of passengers. Printing lets us compare quarter-to-quarter fluctuations. Running the cell now. This output shows the average number of passengers grouped by quarter, revealing seasonal trends over time. Notice how each quarter's mean passenger count changes, with peaks suggesting higher travel demand in certain seasons. This step is key for identifying the peak travel season by summarizing monthly data into meaningful quarterly averages. Quarterly breakdowns are especially helpful for business forecasting. Let us extract the year and full month name from the datetime index. Add a new column extracting the year from the data frame's datetime index. Create another column with the full month name using the datetime index. Display the first few rows of the new columns alongside the passengers column. Previewing helps us double-check that our new columns look right. Running the cell now. Here, we extract the year and month names from the datetime index and add them as new columns to better analyze passenger trends. Notice how the extracted columns align with the original dates, enabling easier grouping or filtering by time periods. This step is key for identifying peak travel seasons by month and year in the next parts of the project. Can you create a season column? You could use month to map to winter, spring, summer, or fall. Now, let us make a simple pivot table for more flexible grouping. Here, we ask Pandas to build a table with year as the index and a month_name as columns. Each cell holds the mean passenger count for that specific year and month. Pivot tables make it very easy to spot unusual years or months. Running the cell now. This pivot table shows the average number of passengers per year, broken down by month, which helps us identify seasonal trends in travel. Notice the shape, rows are years and columns are months, making it easy to compare how passenger numbers grow or decline throughout each year. This output is key to our goal of finding peak travel seasons by highlighting months with consistently higher passenger averages. Pivot tables let you slice and dice your time series almost any way you like. Let us wrap up with some troubleshooting advice for your own time-based projects. Troubleshooting tips. If your resample gives errors, double-check that your index is datetime. If you get missing data or NaN, inspect your data for gaps. Always preview your new tables after any operation. Learning to fix common bugs makes you a real Pandas pro. Running the cell now. Final challenge, can you fix a broken date index if you run into errors? Try converting with PD to _datetime. Let us finish with a quick best practice for efficiency. If you need to sort or filter by a month_name or lot, making it a Pandas categorical is more efficient. You can provide the order so months always sort January to December. This small tweak speeds up many downstream operations. Running the cell now. This output confirms that the month_name column has been converted to a categorical dtype with a specified order from January to December. Notice the datetime index remains intact, and the categories ensure consistent sorting and performance in future operations. This step helps avoid common pitfalls like incorrect sorting or slow processing when working with monthly data. Remember, efficient data types save memory and time for big jobs. Here is a quick recap of all the key skills you have unlocked today. Recap: what did you learn? How to create datetime columns and sort by date. Grouping and aggregating by year, month, or quarter. Resampling, moving averages, and pivot tables for time series. Troubleshooting index and data type issues. With these tools, you can explore trends in almost any time-based data. Running the cell now. You are now ready to use Pandas for time-based grouping in your own analyses. Thank you for learning together. Do not forget this last step. Next steps: like, comment, and subscribe. Practice these ideas with your favorite datasets, sales, weather, or personal logs. Let us know in the comments what time series you want to tackle next. For more data skills, make sure to like and subscribe for future lessons. Running the cell now. See you next time for more Pandas practice.